Hey guys, let's talk about radical equations. I should start off by telling you what a radical equation is. I mean, it's pretty much how it sounds. There's a radical and there's an equation, but this time the variable is going to be on the inside of the radical. So maybe we have something like the square root of x equal to, say, like 8. Basically, what you're being asked is what number has square root equal to 8. Which maybe you could see right off the bat, but the idea is that I want to solve for the variable. I want to get the variable by itself, meaning I should undo whatever operations are happening to it. So if I have the square root of x equal to 8, then I can really just square both sides to get rid of the radical. The square root of x then squared gives me x by itself. The square root and the square cancel out. 8 squared gives me 64. Fine. But the idea is that maybe we'll have more underneath the radical. So maybe I have something like 2x plus 1 equals 9 inside of the square root. I can't subtract the 1. I can't divide by 2. All of this is trapped inside of the radical. So the idea is that I want to undo the radical in order to isolate the variable. I have to square both sides once the radical is alone so that the radical can cancel out on the left. And then on the right, I end up with 9 squared, which is just 81. So I have 2x plus 1 equal to 81, and now it's an equation that I can solve. All right, so let me list out the steps for you guys. The idea is that you want to get the radical completely isolated, completely alone. If you don't have the radical completely alone, like if I have something, say, like 3 plus the square root of x equal to 5, then squaring both sides is no good, because when I square both sides over here, I have to square the entire left-hand side and the entire right-hand side. I can't square piecewise. So really, since it's a binomial squared, I have to take 3 plus the square root of x and multiply it times 3 plus the square root of x. What happens then is you get 9 plus 3 square root x plus 3 square root x. So 9 plus 3 square root x, and then plus another 3 square root x. But then at the end, I have square root x times square root x, so I have a positive x. This looks really bad, and that's because we made the problem harder by not getting the radical by itself. I end up with more radicals than I need, and that's a problem. So what should I do? I should always completely isolate the radical first, get it completely alone, and then square both sides. Like in this case, I should have just subtracted the 3 from both sides so that the square root of x is equal to 2, and now I can solve it. The second step is that once you have the radical by itself, then you raise both sides to the power of the index. Like in this case, I have a square root. If I have a square root, then the index is 2, right? It's not written, but that's how I know to square both sides. If I had a radical equation with like a cube root, say the cube root of x equal to 4, then to undo the cube root, I should cube both sides. That would get rid of the radical, but when I cube this on the left, now I have to do 4 times 4 times 4, raise it to the third power so that I get 64. So these are separate problems. Let me erase that last one. The third step is that once you raise both sides to the power of the index, you're going to have an equation that you know how to solve. Sometimes you're done right away, but like I said in the case of the square root of 2x plus 1 equal to 9, when you squared both sides, when we did that earlier, we got 2x plus 1 equals 81. This is an equation that you know how to solve, so you should finish solving it. The point is, though, that there are 2 types of equations that are going to turn out. Either it's going to be linear or it's going to be quadratic. And I'll show you the case where it's quadratic. That's the case that I want to emphasize the most. The last step is that you have to be careful, because technically the solutions that you get might not actually work. So you do have to check, not check to see whether you got it correct, but check for extraneous solutions. Extraneous solutions are just extra solutions that appear because you did something that may not necessarily have been legal. How do extraneous solutions come up? Well, Let me erase this. The idea is that squaring both sides, it's not necessarily the most legal operation. It does work and it cancels things out, but it potentially creates some problems. Like if I start with a false statement, say negative 2 equals 2. Negative 2 does not equal 2. That's a problem. But as soon as I square both sides, then what do I end up with? I get 4 equals 4. So by squaring both sides, I end up with something that's true. So if I solve it, I might get a solution that should not have worked from the beginning. So you have to be a little bit careful because squaring both sides ruin things. So does raising things to the fourth power and so on. But all you have to do to check is plug them back in and make sure that they both work. All right, so let me show you a few different types. Actually, let me just show you the type that's on the pre-problem of the day, and then that way you can practice. So maybe we have something like x minus the square root of 9 minus 8x equal to negative 18. Let me make that radical a little bit bigger so you see that 9 minus 8x is all under the radical. Remember, the first step is you have to get the radical completely by itself. It would be a really bad idea to square this whole thing. And I cannot square each term. That's not a legal operation at all. It's not a real thing. So you either have to square both sides or isolate the radical and then square both sides. But the problem is now that if you square both sides, it makes the problem worse. So what should I do? I should move the x to the other side, subtract the x over. So that negative square root of 9 minus 8x is equal to negative x minus 18. I still wouldn't square it here. I wouldn't raise both sides to the second power because I still don't have the radical completely alone. It has to be completely isolated. So really I should divide everything by negative 1 so that this becomes a positive square root of 9 minus 8x. And then when I divide these terms by negative 1, I get positive x plus 18. When you square both sides, now that you have the radical isolated, the radical goes away, so that you get 9 minus 8x. That's really nice. It's a little too nice. Some people usually make the mistake then of just squaring each of these terms. Again, you can't do that. If it's x plus 8 squared, you have to do x plus 18, times x plus 18. You have to actually FOIL it out. So in this case, you get x squared plus 18x gives me plus 36x. And then 18 times 18, that's on our squares list. It's just 324. Now in this case that I've squared both sides, I have to ask myself, how do I finish solving this? This is where a lot of people get stuck. And remember, my recommendation to you is that you look at it and you say, okay, I have to solve this thing. It falls into one of two categories. It's either linear, like we have on the left, or it's quadratic. Since this is degree 2, it has a degree 2 equation. This is all a quadratic equation. Meaning you should recognize it as x squared and then remember, oh yeah, I want it equal to 0 so that I can factor, so that I can find the two solutions. So in this case, I should subtract the 9 over, so that negative 8x equals x squared plus 36x plus 324 minus 9 is 315. And then I should also add the 8x over, so that 0 equals x squared plus 44x plus 315. Now this might be a little bit tough. Too many people try to, worry that this is a big number. It might be tough, but the only way you're going to figure out how hard it is to list out the factors. What two numbers multiply to 315 and add to 44? Well, definitely 1 and 315. That works fine. But 3 also works. 3 goes into 315 105 times. 5 also works. 2 and 4 don't because this isn't an even number. But 5 goes into 315 20, 40, 60 3 times. Those don't quite give me 44, but I'm close. So the question is, does 9 go into 315? And it looks like it does. If I add up all the digits, I get 9. 3 plus 1 plus 5 gives me 9. 9 is divisible by 9, so the whole thing has to be divisible by 9. Well, if I divide by 9, I get what, 30? Let's just do it. 9 goes into 105. Oh, yeah. I'm sorry, 9 goes into 315. $35 times. And what you see is 9 and 35 work. If I use a positive 35 and a positive 9, they multiply to 315. They add to 44. Now, that might seem hard, but all I did was write out the factors of 315, and I just went in order, so eventually you'll get there. Now let me use a new page. Let me write out the stuff that we were solving. The original equation was x minus, maybe I should save some space, x minus the square root of 9 minus 8x equal to negative 18. But we've already gotten everything on one side after squaring everything, so we have 0 equals x squared plus 44x plus 315. And we found the two factors that work. This was x plus 9, x plus 35. So then when I take x plus 9 and set it equal to 0, I get x equals negative 9. When I take x plus 35 and set that equal to 0, I get x equals negative 35. The point is that we got two solutions by doing that very long process of solving. I don't know if they necessarily work though, so I do have to check. To check, I just plug them both back in. Like if I take negative 9 and plug that in, negative 9 minus the square root of 9 minus 8 times 9, negative 9. Does that equal negative 18? Well, negative 9 minus the square root of 9 plus 72 is negative 9 minus the square root of 81, which is 9. So negative 9 minus 9 does equal negative 18. It works. So x equals negative 9, that's a fine solution. That doesn't tell me anything about negative 35. I have to check that one also. Negative 35 minus the square root of 9 minus 8 times negative 35. Does that equal negative 18? Well, negative 35 minus the square root of 9 plus whatever 8 times 35 is. Maybe I'll just do it up here. 35 times 8 is 280. And so negative 35 minus the square root of 289, I want to know, does that equal negative 18? But look at your list of squares and find out what is the square root of 289. It's just a little bit bigger than 324 was. Turns out it's actually 17. And here's where you see that it doesn't work. Negative 35 minus 17, that's a bigger negative number. I have to add them together. I get negative 52. It does not equal negative 18. So this negative 35 is an extraneous solution. It's an extra solution that shouldn't have shown up. Why did it show up? Because if I took the square root of 289 and I had got positive 17, negative 35 plus 17 would have been negative 18. But remember, when you square both sides, you take something that's potentially false and make it true. That's the same thing that's happening in this step. Let me do one more, and let me make the numbers a little bit nicer so that it's a little more friendly. Those numbers got very big. Let's try this one. They're a little smaller. What if I have x minus the square root of 5 minus 4x equal to negative 10? Same idea. You got to get the radical completely alone. You should identify the problem first. The problem is that I want to solve for x. I have an x on the inside of the radical. I have an x on the outside of the radical. How am I going to get them together? Only if I can get rid of the radical. Well, then there's a process to get rid of the radical. You move the x to the other side. You subtract the x over so that you get the negative square root of 5 minus 4x equal to negative x minus 10. And you could write it in any order, but I'm already looking ahead and seeing that I'm going to divide everything by negative 1. So I get the square root of 5 minus 4x equal to positive x plus 10. Here's the key step then. Now that the radical is completely alone, I can square both sides. The radical cancels out with the square on the left so that I get 5 minus 4x. But on the right, I have x plus 10 times x plus 10, which gives me x squared plus 20x plus 100. So if I subtract the 5 over, I get negative 4x equal to x squared plus 20x plus 95. And then if I add the 4x to the other side, I get 0 equals x squared plus 24x plus 95. Again, you should pause for a second and say, be like, what the heck is he doing? Once I get this out of the radical, you have to look at this and say, well, what kind of equation is it? If it's degree 2, you want it equal to 0, so you should move everything over. If it's degree 1, you know how to solve those. Those I don't think anybody ever gets stuck on. So recognize, look for the power. If there's a degree 2, move everything over, get it equal to 0 so that you can factor. What two numbers multiply to 95 and add to 24? Well, if I write out the factors of 95, it's 1 and 95, 5 and 19. Well, then, those are the only factors of 95, and they work. Positive 5 and positive 19. Since a equals 1, I can just take the shortcut. This becomes x plus 5, x plus 19. So I get two answers. X equals negative 5 and x equals negative 19, from setting each of these equal to 0. So you got to isolate the radical completely and then square both sides. You'll be left with something that you know how to solve, so solve it. The problem is they may not both work. Maybe negative 19 works, maybe negative 5 doesn't. Maybe negative 5 works, maybe negative 19 doesn't. Maybe they both don't work. If they both don't work, that's no solution. But anything could happen here. So you have two equations, or two answers, you have to check them both. Let me just take this over to a new page. Whoops. If I want to check my two answers, I'll start with x equals negative 5. Negative 5 minus the square root of 5 minus 4 times negative 5. Does that equal negative 10? Well, negative 5 minus the square root of 5 plus 20 does seem like it works, because negative 5 minus the square root of 25 is going to be negative 10. The square root of 25 is 5, which gives me negative 10. It works. But then the question is, what about negative 19? Does negative 19 minus the square root of 5 minus 4 times negative 19 work? Does it equal negative 10? Well, negative 19 minus the square root of 5 plus 4 times 19 is 76. Doesn't seem like it's going to work, because I get negative 19 minus the square root of 81 equal to negative 10. And so look out for this. Like, the square root here is 9. If it had been negative 19 plus 9, it would have worked. But when I take the square root, it becomes negative 19 minus 9, and that's the problem. That's why it's extraneous, because that negative 9 was supposed to be a positive 9, so that when I squared them, they became the same value. I didn't know the difference between, and it created that issue. Anyway, it doesn't work, so this answer, I should cross it out, throw it out, say that it's extra, say that it's extraneous. Only input this one answer into MathXL. If you put more in, it's going to say, hey, you're correct, but don't forget about extraneous solutions if you put in both. So you should only put in -5 because that's the only solution. All right, so try out the problems. They're just like these two. You can watch the video a few more times if you need to. The numbers might get a little bit big, and so I'm sorry for that, but we'll do a bunch of examples in class. All right?